All right, guys, so we're going to go back quickly to chapter 5 for one quick section prior to moving on to section 6.6. We have to review graphing linear inequalities. Okay, linear inequalities, all they are, a linear inequality is similar to a linear equation. The only difference is this. The equal sign is going to be replaced by one of these four symbols. It's either going to be a less than or equal to, greater than, or greater than or equal to. Okay, linear inequalities have one of these four symbols instead of the equal sign. Okay, there are no equal sign when it comes to linear inequalities. Okay, but a solution to a linear inequality is any ordered pair that makes the inequality true. Okay, so for example, A and B here, we're going to solve, to check to see if this point is a solution to this inequality. Okay, so I'm given the statement y is less than x plus 1. And I want to know if 4 comma 5 is a solution to this inequality. Okay, so all I have to do is I have to plug this coordinate into this inequality to check to see if it makes a true statement. So the first number is x, and the second number is y. So I'll plug in 4 for x, 4 plus 1 on the right, and then on y is 5. So I ask myself this question. Is 5 less than 4 plus 1, which is 5? Is 5 less than 5? No, it is not. Okay, it might be equal to, but it's not less than, so this is not a solution. No, it's not a solution. Second one, it says solve. Is y greater than x minus 7? Is this point 1 comma 1 a solution to this inequality? So once again, I plug and chug. I plug in 1 for y. 1 is greater than 1 minus 7. Do a little bit of math. Is 1 greater than negative 6? Yes, it is. 1 is definitely a bigger number than negative 6. Yes, this point is a solution. Okay, there's going to be infinitely many points that meet this requirement, but 1 comma 1 is an example of a solution that works. Okay, we're going to keep moving on. We're going to skip that blank for now. We're going to talk now about graphing linear inequalities. Okay, they're kind of like graphing linear equations, but there's just a few extra pieces we have to account for. There's different types of lines, and there's also shading that we have to account for. Okay, so when the inequality symbol is written as greater than or equal to or less than or equal to, either one of the signs that have a line underneath it, okay, the line is going to be solid when we graph it. Okay, we're going to graph it just like a linear equation, but we're going to make sure that it's a nice solid line as it's going up and down or left and right. Okay, it's still going to be a solid line, but in contrast, if the inequality is greater than or less than, okay, the line that we draw is going to be dotted, similar to the one we see down here. Okay, dotted line has spaces in between each little point. Okay, so as you draw with your ruler, just make sure you're putting spaces in between if you have one of these two symbols. Okay, there's a line texture and there's also a line shade. We're going to shade either above the line or below the line every single time. So when the inequality is either greater than or equal to or greater than, the shaded region is going to be above the line. We're just going to color in above the line. Be somewhere up here for this one or somewhere up here for this one. And then when the inequality is either less than or equal to or less than, the shaded region is below the line. Be down here or down here. Anything underneath the line that we sketched. But in short, it's pretty much the exact same thing as graphing equations in slope-intercept form, but there's just two extra pieces. The line texture and the shade. So what are the steps for graphing linear inequalities? First step is to solve the inequality for y. Get y all by itself. Then we have to ask ourselves, what's the texture? Is it solid or is it dashed? Then ask yourself, where is the shade? Is it above or is it below? Okay, so it says graph the solutions of each linear inequality. Okay, graph what we see here. So fortunately, for example A, we're already in slope-intercept form. Y is by itself, and I'm in the format mx plus b. Okay, so we're going to graph this first just like we would any other linear equation. My y-intercept is at positive 1. and my slope is negative 2/3. Okay, so from this point, I'm going to go down 2, 1, 2, over 3, 1, 2, 3. Got a point? Let's get one more. Go down 2, 1, 2, over 3, 1, 2, 3. Okay, and just for good measure, maybe I'll go in the opposite direction once. I'll go up 2, 1, 2, and then over 3 to the left. 1, 2, 3. Okay, so before I connect the dots, I have to ask myself this question. Is it dotted or is it solid? The way I determine if it's dotted or solid is I have to look underneath the inequality symbol. Okay, if I see that solid line underneath the inequality symbol, it's going to be a solid line. So when I connect the dots, it's going to look just like this, just like we would any other linear equation. Okay. Then I ask myself, am I going to shade above the line or below the line? Okay, if we look back at our chart, the symbol we see here is greater than or equal to. Okay, if our symbol is greater than or equal to, we're going to shade above the line. Okay, so basically what you do is you start on the line and you think, okay, what is above it? Anything in this sweet spot over here. Anything that is pointing up from the line we just drew. So what I'm going to do is I'm going to shade the entire area that is above the line that I just sketched. This inequality has two characteristics. It's a solid line, and I shade above. Other than that, it's basically just graphing a line in slope-intercept form. Okay, now let's look at example B. Once again, they were super nice to me. They already put it in slope-intercept form. I don't have to do anything to it. So I ask myself first, is it dotted or is it solid? Okay. I see the less than symbol. I don't see a line underneath, so this is going to be a dotted line. Okay, but let's get some points first. It's already in slope-intercept form, and it looks like my y-intercept is equal to -5. Y-intercept, or excuse me, -4. -4. So I go 4 units down. 1, 2, 3, 4, and that's my first point. And then my slope is 4 over 3. M is equal to 4 over 3. So from that y-intercept, I'm going to go up 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. And I got a second point. And I can do it once again for good measure. I can go up 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. Okay, so before I play connect the dots, I got to remember, okay, this is a less than symbol. And less than means my line is going to be dotted. So as I connect my dots, it's going to look something like this. It's not going to be some nice solid line with perfect connect the dots. I'm basically skipping a little bit between each dash. Okay, it looks exactly the same, but instead, just a dotted line. Then I ask myself, okay, do I shade above or below? And the symbol I see here is less than, okay? Less than and less than or equal to both mean the same thing. They both mean that I'm going to shade below. Shade below. Start on the line you just sketched and then shade everything underneath it, which would be down here. Any point that falls in this big, large region would classify as a solution to this inequality. Okay? This is basically the exact same thing as graphing things in slope-intercept form, but there's two extra things you have to account for. The line texture and where is the shade at.